Hello everyone, welcome to our YouTube channel GKR Soft. In this video, we are going to discuss about E-bar-E architecture. E-bar-E architecture is nothing about electrical or electronic architecture. First, we can understand about some of the history, what happened in the automotive industry, and from when onwards, industry started to talk about E-bar-E architecture. In the pre-1960s, we have used only a basic electrical system. At that time, there was no ECU were introduced in vehicle. In 1970s, we started to use the ECU that specifically for a engine control purpose. So the introduction of electronic fuel injection and electronic ignition system that lead to the first use of microcontrollers in vehicles. From there onwards, we started to talk about E-bar-E architecture. In the 1980s, we started to use the CAN bus. That's specifically for make a communication between one ECU to another ECU. In around 2000, we started to use the AutoSAR because the ECU number got introduced, and at the time the industry were looking to standardize the software. For that purpose, AutoSAR were introduced. In the 2010 time, we started to talk about connected cars. From there, we started to talk about domain centralized architecture as well. In 2020 until today, we are talking about a software defined vehicles because with the advancement of artificial intelligence and cloud computing, so currently everybody is talking about a software defined vehicle. In this video also, we are going to talk about what all are the architectures we have under E-bar-E and how we can use this. First, we can start with what is E-bar-E architecture. So E-bar-E architecture is nothing about electrical or electronic architecture. And this refers the overall design and organization of electrical and electronic systems within a vehicle. It defines how ECUs and sensors, actuators, communication networks, and software components to interact vehicle functionality. That's also will be ensured by E-bar-E architecture. And this also serves as the backbone for all modern vehicle functionalities from basic lighting to ADAS and autonomous driving. And the key features of E-bar-E architecture is ECU organization, communication networks, power distribution, software structure, and functional safety and security. Now we can talk about the evaluation of E-bar-E architecture. Under E-bar-E architecture, we have a distributed architecture, domain-based architecture, centralized architecture, and zone-based architecture. In distributed architecture, each function has a dedicated ECU. So for an example, each functionality will be taken care by a dedicated ECU. So, but this will lead to the complexity and high wiring cost. So this is called as a traditional architecture. So meaning distributed architecture is a traditional architecture and this is used in all legacy vehicles. And domain based architecture. Here ECUs grouped by domains. Example powertrain, chassis, infotainment. Centralized architecture. Here industry were used central ECUs to handle multiple functions. Next one is zone based architecture. Here ECUs organized by physical zones. Example front, rear with centralized compute power. Now we can discuss about more detail about each and everything. One first we can start with distributed E-bar-E architecture. See here, here we have a central gateway and each and every functionality will be handled by separate and dedicated ECU. In domain centralized E-bar architecture, we will have a central gateway, but ECUs are grouped by domain. In zonal E-bar-E architecture, we will have one HPC, high performance computing unit, and we will have a zonal ECUs. So here everything will be considered as a zonal. So first we can start with distributed architecture. You can see the picture here. Each and every function we have a dedicated ECU. So multiple ECUs here were used in the distributed architecture. And in the distributed architecture, advantages is improved reliability and more flexibility. If one ECU fails, others can continue functioning. And flexibility meaning it's easier to integrate new features and cost efficiency also. For an example, ECU can be optimized for their specific task. So here it will reducing the hardware cost. But what are the challenges we have in the distributed architecture? So here requires efficient network design and more ECU, more wiring and weight also will get increased. And data transmission delays can impact the performance. And maintenance also would be a challenging one in the distributed architecture. The next one is domain based architecture. In the domain based architecture, everything will be grouped as a domain. So, for an example, logical grouping of ECUs into domains. So, here the number of ECUs will get reduced. And what are the advantages we have in domain based architecture? Fewer ECU and reducing complexity and weight. And the performance will get improved here. And the communication is very simpler here. The reason is high-speed Ethernet connects domain controllers efficiently, and security and safety also improved in domain-based architecture. Then what are the challenges we have in domain-based architecture? Here, the domain controller complexity, meaning needs high computing power to manage multiple functions. And software integration would be another challenging in domain-based architecture. So each domain may have a different software stacks that need coordination and higher initial cost also in domain based architecture. The next one is zonal architecture. The zonal architecture ECUs grouped by vehicle zone. So instead of functional domain, for an example, powertrain, body, ADAS, here ECUs are grouped by vehicle zones. For an example, front left, front right, rear left, rear right, and center. And here we are using a zonal controllers and centralized computing. Then what are the advantages in the zonal architecture? So here the ECU numbers are reduced. Fewer ECU, less complexity, and less weight and less cost. And wiring also very simpler in zonal architecture because shorter wires within zones. And performance will get improved here, and also safety and security. And zonal architecture supports software defined vehicle. So hardware is separated from software to allowing over the air updates and new feature deployment. Then what are the challenges we have in zonal architecture? Here, high performance computing is required, needs more powerful processors and high speed networking. And software integration is more complex here. It will require advanced middleware for communication between zone and central units. And the transition complexity is more in zonal architecture. To move from traditional issue to zonal architecture to requires redesigning vehicle software and hardware. That is a very big challenge in the zonal architecture. Now, in today trends, how we are using this modern E bar E architecture. For an example, we have a service-oriented architecture that uses standardized software services for flexibility and over-the-air updates. It will enable the remote software update and high-performance computing and AI and machine learning. So these all are the trends in modern E bar E architecture. In another video, we will deeply discuss about each and every functionality. Hope you get a clear idea about how E bar E architecture works and what are the advantages and disadvantages are there for each and every architecture. Thank you so much. Have a nice day.